In the arid landscape of California's Central Valley, where vast fields once thrived, a relentless drought tightened its grip for years. Farmer John Miller, a third-generation grower, watched his family's legacy wither under the scorching sun. The once fertile earth, the bedrock of their livelihood, had turned to dust, a stark testament to a changing climate. It was a crisis unfolding not just for John, but for an entire nation reliant on traditional farming, pushing innovators to reimagine how we put food on our tables, especially something as simple as a fresh salad. Thousands of miles away, in a quiet university lab, Dr. Evelyn Reed, a visionary agricultural scientist, had spent years perfecting a radical idea. Her motivation wasn't just about efficiency, it was about resilience. She envisioned a future where food production wasn't hostage to unpredictable weather or dwindling resources. Her focus, unlocking the potential of soil-less cultivation, a method that promised to revolutionize farming, making fresh produce accessible even in the most challenging environments. By late 2018, Dr. Reed had secured a small but crucial grant, enough to build a prototype. The initial results were promising, but the scale she dreamed of required an unprecedented leap of faith and capital. She presented her audacious plan, America's largest soil-less salad greenhouse, a controlled ecosystem designed to feed millions. Skepticism was rampant. The sheer audacity of her vision seemed almost insurmountable, yet her conviction was infectious, drawing a few key investors to her cause. 2 years later, in early 2021, the chosen site in rural Arizona began to transform. It was a location strategically picked for its abundant sunlight and proximity to major distribution hubs, yet far from prime agricultural land. What started as a vast, empty expanse slowly gave way to a skeletal structure of steel and glass, sprawling across hundreds of acres. This wasn't just a greenhouse, it was an industrial-scale monument to a new era of agriculture, visible from miles around, drawing curious gazes. Leading the intricate engineering challenge was Mark Chen, a brilliant systems engineer with a background in aerospace. Mark's task was monumental: to translate Dr. Reed's biological vision into a robust, scalable mechanical reality. He faced countless sleepless nights, designing custom nutrient delivery systems, climate control arrays, and complex irrigation networks that would mimic nature's perfection, all within a colossal enclosed environment. His passion for precision was crucial to the project's success. At the heart of Dr. Reed's innovation lay hydroponics and aeroponics, methods that eschew soil entirely. Instead, plants receive all necessary nutrients directly through water. This approach offers staggering efficiencies. Traditional farming loses significant water to evaporation and runoff, but in a controlled environment, water can be recycled, drastically reducing consumption. This efficiency was not merely a benefit, it was a necessity, especially in drought-prone regions, making every drop count for maximum growth. The difference between traditional farming and this new approach is stark. On one side, vast tracts of land, heavy water consumption, and vulnerability to pests and weather. On the other, a compact, climate-controlled ecosystem that promises consistent yields year-round. It's a fundamental shift in philosophy, moving from battling nature's whims to collaborating with scientific precision. This comparison highlights not just efficiency, but a paradigm shift in how we secure our food future. Inside the greenhouse, thousands of young lettuce plants are carefully placed into custom-designed growing channels. Beneath them, a constant flow of nutrient-rich water bathes their roots. Each batch of water is precisely formulated, a custom cocktail of minerals and elements, tailored to the specific needs of each lettuce variety at every stage of its growth cycle. Mark Chen's team developed a sophisticated system that monitors and adjusts these levels in real time, ensuring optimal health and accelerated growth. The entire greenhouse operates as a living laboratory, a symphony of sensors gathering vast amounts of data. Temperature, humidity, CO2 levels, pH, dissolved oxygen, every parameter is meticulously tracked. This constant stream of information allows for instantaneous adjustments, ensuring the environment remains perfect for the plants. It's an unprecedented level of control, far beyond anything possible in an outdoor field, preventing problems before they even have a chance to take root. To manage such a vast operation, automation is key. Robotic systems handle everything from seeding and transplanting to harvesting, working tirelessly around the clock. These machines move with uncanny precision, ensuring minimal waste and maximum efficiency. It's a fascinating dance of technology and biology, allowing the facility to process an unimaginable volume of produce with a fraction of the labor traditionally required, a silent army tending to the endless rows of green. With optimized conditions and a constant supply of nutrients, the lettuce grows at an astonishing rate. What might take weeks in an outdoor field can be harvested in a matter of days here. This accelerated growth cycle means a continuous supply of fresh produce, unaffected by seasonal changes. It's a crucial advantage for meeting the demands of millions, ensuring that supermarket shelves can always be stocked with vibrant, fresh greens, regardless of the time of year or external conditions. The initial planting phase, in mid-2022, brought its own set of challenges. Despite meticulous planning, the sheer scale of the operation meant unforeseen issues emerged. A subtle pH imbalance in one of the nutrient zones led to stunted growth and a significant block of romaine. Dr. Reed and Mark Chen worked tirelessly, debugging systems and analyzing data, understanding that every small adjustment could have cascading effects across the massive facility. It was a baptism by fire, testing their resolve. Through trial and error, the team refined their processes. Each small setback became a valuable lesson, feeding into an ever-improving system. They discovered the delicate balance required for each lettuce variety, from the robust butterhead to the more sensitive spring mix. This iterative process of learning and adaptation was crucial. By late 2022, the initial glitches were largely ironed out, and the greenhouse began to hum with predictable, productive efficiency, a testament to relentless problem-solving. The anticipation on the first full harvest day was palpable. Early 2023 marked a pivotal moment. Trucks were lined up, ready to transport the first bountiful yield of fresh, vibrant lettuce. Dr. Reed and Mark Chen stood among their team, watching robotic arms meticulously cut and package the greens. It was the culmination of years of tireless work, a silent victory against skepticism, and a tangible step towards a more sustainable food future, fulfilling a promise once considered impossible. Within weeks, the fresh greens from the Arizona greenhouse began appearing on supermarket shelves across the western United States. Consumers, accustomed to produce that traveled thousands of miles, noticed the difference immediately. The lettuce was crisper, more flavorful, and had a noticeably longer shelf life. This was not just about growing food, it was about delivering superior quality and freshness, directly impacting the daily meals of millions of families. Beyond quality, the environmental benefits of the greenhouse are profound. By growing vertically and reusing water, the facility uses dramatically less land and a fraction of the water compared to traditional field farming. This means precious natural resources are conserved, and the ecological impact of agriculture is significantly reduced. It offers a blueprint for how to feed a growing global population without depleting the planet's finite resources, addressing critical issues of sustainability. One of the often overlooked environmental impacts of food production is food miles, the distance food travels from farm to plate. By strategically locating the greenhouse closer to population centers, the facility drastically cuts down on transportation emissions. This not only benefits the environment but also ensures the produce arrives fresher, minimizing spoilage and waste. It's a holistic approach to sustainability, considering every step of the supply chain. The operational metrics are staggering. The greenhouse now produces several 100,000 pounds of lettuce varieties every single week. This consistent output provides reliability for food suppliers, preventing price fluctuations and ensuring a steady supply. These numbers aren't just statistics, they represent access to healthy food for underserved communities and a more stable food economy, offering tangible proof of the facility's impactful success and scalability. Being a controlled indoor environment offers another immense advantage: protection from pests and diseases. This dramatically reduces, or often eliminates, the need for chemical pesticides. This means the lettuce grown here is not only clean and fresh but also free from harmful residues, offering peace of mind to consumers. It's a significant step towards cleaner eating and a healthier planet, demonstrating the power of prevention through precise environmental control. However, such an advanced operation isn't without its own set of challenges. One of the primary concerns from the outset was energy consumption. Maintaining ideal temperature, humidity, and lighting across hundreds of acres requires a substantial amount of power. Critics questioned the true green credentials if the energy source wasn't sustainable. This was a tension point that Dr. Reed and her team knew they had to address head-on to truly fulfill their vision. To mitigate the energy challenge, the team invested heavily in renewable energy. The vast, flat roofs of the greenhouse became home to thousands of solar panels, generating a significant portion of the facility's electricity. This commitment to green energy underscored their dedication to true sustainability, transforming a potential weakness into a powerful statement about responsible resource use. It was a complex, multi-million-dollar undertaking, but one they deemed absolutely essential. Another innovation involved minimizing waste. Unsellable greens, those with minor blemishes or excess biomass, aren't simply discarded. Instead, they are channeled into a sophisticated composting and biodigester system. This process converts organic waste into nutrient-rich compost for other agricultural projects or even biofuel, creating a truly circular economy within the farm. It ensures that every part of the plant life cycle contributes to a sustainable outcome, reducing landfill burden. Far from eliminating jobs, the greenhouse created a new class of employment in the rural community. While automation handles repetitive tasks, skilled technicians, agronomists, engineers, and logistics experts are required to operate and maintain the complex systems. These are often higher-paying, specialized roles that contribute significantly to the local economy, providing opportunities where traditional farming jobs had diminished due to mechanization and consolidation. Recognizing the importance of sharing their knowledge, Dr. Reed's team established an educational outreach program. Local schools and universities now visit the facility, learning about sustainable agriculture, engineering, and plant science firsthand. It's an investment in the next generation of innovators, inspiring young minds to pursue solutions for global food challenges, showcasing what's possible when science meets ambition, and fostering a sense of community engagement. For a lettuce plant, life inside the greenhouse is a highly optimized journey. From tiny seed in a nutrient-rich cube, to a lush, full-grown head, its entire existence is carefully managed. It moves along conveyor belts, receiving precisely what it needs, when it needs it, under ideal light and temperature. There's no struggle against harsh weather, no fight with pests, just continuous, pampered growth. It's a vision of efficiency, ensuring every plant reaches its full potential. Despite all the technological marvels, the ultimate test is always taste. Initial skepticism regarding the flavor of soil-less lettuce quickly faded. Blind taste tests consistently rated the greenhouse greens as superior in crispness and flavor compared to conventionally grown varieties. The control over nutrients and environment translates directly into a product that excels not just in sustainability but also in sensory appeal, winning over even the most traditional palates. The impact on local communities extends beyond jobs. Access to fresh, affordable, high-quality produce year-round has tangible health benefits. For many, fresh salads were once a luxury or seasonal treat. Now, they are a consistent, accessible part of a healthy diet, helping combat food deserts and improving overall public health outcomes in surrounding regions, creating a ripple effect of positive change. This is food security made real and accessible. With the initial success firmly established, Mark Chen's team is constantly looking for ways to further optimize and expand. New growing techniques are being tested, and a broader variety of greens are under development. The existing infrastructure is a robust platform for further innovation, paving the way for even greater production volumes. The goal isn't just to maintain current output, but to responsibly scale to meet ever-increasing demand for fresh, local food. What started as Dr. Evelyn Reed's ambitious dream has evolved into a fully operational, highly efficient, and environmentally responsible agricultural powerhouse. This facility isn't just America's largest soil-less salad greenhouse, it's a living model, demonstrating how food can be grown sustainably anywhere in the world, regardless of climate or soil quality. It offers a tangible solution to global food security challenges, inspiring similar projects worldwide. The implications of this kind of farming extend far beyond salad. The technology and expertise developed here could eventually be applied to a wider range of crops, transforming urban areas into productive food zones and bringing fresh produce to remote regions. It paints a picture of a future where food is grown closer to where it's consumed, with minimal environmental impact, ensuring healthier diets for all. Dr. Evelyn Reed now stands at the forefront of a revolution she helped ignite. Her initial vision, once met with skepticism, has blossomed into a thriving reality. Her motivation remains the same: to create a resilient food system for generations to come. This greenhouse is more than just a farm, it's a testament to human ingenuity and perseverance, proving that with bold ideas and relentless dedication, even the most fundamental challenges can be transformed into opportunities for a better tomorrow. Back in the Central Valley, farmer John Miller occasionally drives by the news reports of this massive Arizona greenhouse. While his own farm still grapples with water scarcity, he sees a glimmer of hope in these innovations. The drought may persist, but the conversation has shifted. There are new ways to grow, new ways to sustain, and new ways to ensure that future generations won't face the same daunting challenges of dwindling resources. A promise of plenty, even in the face of adversity. Every single day, the automated systems hum, the lights shine, and the water flows, nurturing countless plants. Every day, fresh, crisp lettuce leaves the facility, bound for millions of dinner tables. It's a continuous cycle, a marvel of engineering and biological science working in harmony. The silent revolution continues, greening our plates, securing our future, and proving that sometimes, the most profound changes begin by simply asking, what if we didn't need soil at all?